Hello everybody, welcome to the presentation. So we are continuing our problems. Now we are going to solve or we are going to find the shear forces and bending moments, maximum shear force and bending moment for a simply supported beam for the moving load conditions when there are two concentrated loads. So our given problem is 2 point loads 10 kilonewton and 5 kilonewton, they are 3 meters apart. So we have two loads are given, one is 10 kilonewton and another is 5 kilonewton, and these two concentrated loads are placed 3 meter apart. The distance between these two loads is 3 meter. Now the span length, the total span length is 10 meter. The smaller load of 5 kilonewton is leading. That is, the loads are moving from left to right. When moving, 5 kilonewton load moves first. That's why we call it as leader, moving first. So 5 kilonewton load moves first. And we are asked to find the maximum shear and moment. Maximum shear and moment at a section of 4 meter from the left hand support. So we have taken this section at a distance of x is equal to 4 meter from the left hand support. Now we all know how to draw the influence line diagram for shear force and influence line diagram for bending moment. So for a section at a distance of 4 meter, we have drawn the influence line diagram for shear force and influence line diagram for bending moment, and we have obtained the ordinates, maximum negative ordinate, maximum positive ordinate. So maximum negative ordinate in the influence line diagram is x by L. So by substituting the value for x is equal to 4 meter and L is equal to 10 meter, we get x by L is equal to 0.4. And here by substituting the values for x and L, we get the value for L minus x by L. That is the positive ordinate is 0.6. We add these both, 0.6 plus 0.4, it is equal to 1. Always the total of the ordinates should be equal to 1. And for the bending moment, the ordinate is x by L into L minus x. By substituting the value for x and L, we obtained the value as 2.4. Now it's our time to find the maximum negative bending moment. Maximum negative shear force. So for obtaining the maximum negative shear force, we are placing the leading load, that is 5 kilonewton load at C. We are placing the 5 kilonewton load at C. So the 10 kilonewton load is 3 meter away from 5. We are noting the ordinate in the negative portion. That is in this portion. This is our negative portion. So we are marking our ordinate in the negative portion. We are applying similar triangle principle and we got the value of the ordinate is 0.1. So this is 0.1. Now it is our aim to find the maximum ordinate. So our maximum negative ordinate is this load 5 kilonewton multiplied by this ordinate, that is 4.4. This is minus 0.4 plus this 10 kilonewton multiplied by minus 0.1. So we get the value as minus 3 kilonewton. So this is our maximum negative shear force. Same way, we will find the maximum positive shear force. So for finding the maximum positive shear force, we are moving the loads and we are placing this 10 kilonewton load at the section C. The reason is only when we are placing this 10 kilonewton load at C, we will get the maximum maximum shear force. So we are finding the ordinate under the 5 kilonewton load by applying similar triangle principle, and that is equal to 0.3. Now the maximum positive shear force is equal to the magnitude of the load 10 multiplied by the ordinate 0.6 plus 5 multiplied by the ordinate 0.3. We get 7.5 kilonewton. Now it's time to find the bending moment. For bending moment, we know we have only the positive ordinate. Now our condition, see, when there is a train of moving loads, train of concentrated moving loads moving from left to right, we know the condition for maximum bending moment is when one of the load is placed at the section. So we have two loads, a 10 kilonewton load and a 5 kilonewton load. So when one of the load is placed at the section, we will get the maximum bending moment. So we do not know which load. So we have only two loads. So we will find both the condition. We will take case 1. We will be placing this 10 kilonewton load at the section. So by placing this 10 kilonewton load at the section, by using similar triangle principle, we are finding the ordinate under 5 kilonewton load, that is 1.2. Now the bending moment at C is obtained by multiplying the magnitude of the load by the ordinates. That is this 10 multiplied by this ordinate 2.4 plus this 5 kilonewton multiplied by this 1.2. So we get bending moment at C is 30 kilonewton meter. Now case 2, we will place our 5 kilonewton load at the section. By placing 5 kilonewton load at the section, we will find what is the ordinate under the load of 10 kilonewton. So by applying similar triangle principle, we obtained the load under 10 kilonewton, that is Y2 is equal to 0.6. Now bending moment at C is equal to this 10 kilonewton, 10 multiplied by the ordinate 0.6 plus 5 multiplied by the ordinate 2.4. So we get the value as 18 kilonewton meter. By comparing both, we find that the first case has the maximum bending moment. That means maximum bending moment at 4 meter from left support is when 10 kilonewton load is placed at the section, and the maximum bending moment at C is equal to 30 kilonewton meter. Thank you.